Chapter 5, Section 1, Example 3. $7,500 loan is amortized with 4 semi-annual payments. So 1, 2, 3, 4. And they're every 6 months. Construct an amortization schedule based on a 9.8%, so R is 0.098, compounded semi-annually, so I is 0.098 over 2, and we know that N is 4 because there are 4 payments. Okay, so again, first thing we notice here is we're not told what that regular payment is, so we have to find that first. So we get R equals 7,500 times I, 0.098 over 2, over 1 minus 1 plus 0.098 over 2 to the negative 4. Now I'm going to let you do that one on your calculator on your own. When we plug it in, we get 2,110 and 177, okay, and change. But we're again going to round to the nearest penny, so we're looking at the second decimal place. The 7 tells us to round that one up. We would do that anyway because it's a payment. So then we're going to take $2,110.18 as our regularly scheduled payment. Okay, so now we're going to take that and we're going to construct a table. So go ahead and take a moment and construct a table. You will need 1, 2, 3, 4, 5. I believe I needed one more. So you'll need a table that has about 6 lines to it at least. More is better. And then you'll need 1, 2, 3, 4, 5 columns. Okay? Let's go ahead and take a minute and then unpause when you're ready. Alright, now that you're ready, first column is going to be your payment number. Okay, so we always start with 0, and then we go 1, 2, 3, and 4. 4 is going to be all the payments, because again here our N is 4. In the next example, we'll do one with a lot more payments. Okay, your second column is going to be your regular payment, R. Okay, so that's going to be the same all the way down except for this last line. The last line, things are going to change, so don't fill that out quite yet. The next one is interest paid. So I'm going to call that I, okay? And I, big I, is your interest paid. That's going to be equal to your little I times the previous balance. Okay, what do I mean by previous balance? As I mean that if I'm finding this one, right, if I'm on line 1, then I'm going to use line 0. My balance is going to be over here, and I'm going to multiply by I, and that's what's going to go right here. You'll see what we mean when we work this out. Your next column is the principal paid. Okay, this is going to be equal to R minus I. So we're going to take this column and subtract this column, and that's going to be this column. And then our last one is the balance on the loan. Okay, so this is going to be the new balance is equal to the previous balance minus the principal paid. Okay, so it's going to be this minus this to give me this. Okay, so it's going to work a little different again in that last row, but that's the idea. So in our first row, we don't have a regular payment. We just took out the loan. We haven't paid interest or here, so this first row is entirely blank except for 0, and then over here in our balance we put our loan amount, 7,500. In the next row, our regular payment is going to be what we found up here, $2,110.18. Okay, so then we're going to take the interest paid. So to make my calculations easier, I'm going to take that I, 0.098 over 2, and I'm going to store it as A just for quick recall so I don't have to keep retyping it over and over. So I'm going to take my 7,500 and multiply that by that rate. So we get 367.50. And now we're going to take that $367.50 and subtract off the regular payment. So $210.18 minus that answer. So we get $1742.68. And then we're going to get our new balance. We're going to take the $7,500 minus that last answer we just did. So we get $5,757.32. Okay. Notice here, if I have any decimals, I'm always putting 2 decimal places because we're dealing with money, and again, money has cents to it. So let's do it again for number 2. So we're going to do the same process. Our regular payment hasn't changed. It's still $2,110.18. Interest paid is now going to be based off of this $5,757.32. So I'm going to take that and multiply it by my A. So I get $282.11 rounding to the nearest penny. So I take my regular payment, I subtract the $282.11. So I get $1828.07. So notice my interest rate went down and my principal went up. Okay, there's always going to be that dynamic here. One of them's going to go down and one of them's going to go up. It's called an inverted relationship. You don't need to know that, but just some more math for you. Okay, and then I'm going to take that answer and I'm going to subtract it from 57.32. So 392925. Okay. So we're going to take that 392925 and multiply it by A. So we get $192.53. Our payment is still the same R, so $2,110.18. And then our principal paid is going to be our R minus this answer. So $1917.65. Okay, and then we're going to take 392925 and subtract off 1917.65. So we get 2011.60. Now this last line is going to work differently and we're going to work it backwards. Okay, so work the last line backwards. Okay, so what we mean by backwards is our balance here, we're paying something off, so our balance should be 0. So that means that our principal has to be right now what we have as our balance, $2,011.60. Okay. Now we're still going to find our interest paid the same way. So we're going to take that $2,011.60 and multiply it by our interest rate, that 0.098 over 2. So we get $98.57. But then this time to get our regular payment, because that last payment's always going to be just a little bit different, we're going to add these two together to get this one. Okay, so for this one, we take the last I plus the principal, okay, and add them together. So we get 2011.60 plus 98.57, so 2,110 and 17 cents. So again, it's a little different, but it's the same process.